Alright, let's get started with the Chapter 8 review. Number 1 here, we want to solve these equations by the square root property, which is a pretty nifty, easy to use property. All you have to do is get x squared by itself to start off. So here, there's a 3 next to x squared that we want to get rid of. So we divide by 3 on both sides and get x squared equals 21 divided by 3. We can do that and get 7. And the square root property says that to get rid of this squared, we can square root both sides. So we do that and we get x equals, but you have to remember that every time you square root in an equation, when you personally do it, you put that square root there. You have to put a plus or minus, and then square root of 7 we can't simplify into anything. We can't figure out what it is unless we use our calculator to get a decimal, which we don't want to do. So we leave it as square root of 7, and that means this is our answer right here. On number 2, it looks a bit more complicated, but it's really not bad. You just square root both sides because everything on the left side is squared. We can do that. We can just square root both sides. It gets rid of that squared so that all we're left with on the left is x plus 3. Since we took a square root, we need a plus or minus square root of 17. So we subtract 3 from both sides. Now we can't actually put these two numbers together because one's a radical and one's not, so we just write them next to each other as negative 3 plus or minus square root of 17, and that's our answer. Now these next couple, they might seem tricky, but they're really supposed to be pretty easy. It says complete the square for the binomial. What that means is figure out what to put here so that what we have will factor into 2 parentheses where we get the same parentheses for both. So to do that, you take the number in front of x, you divide it by 2, and then you square it. Complete the square. It means you divide by 2 and square. So we get 25. That means that in this blank, I would put a plus 25 because that is what it takes so that I can factor this into 2 parentheses now, where I say what multiplies to get 25 that adds to get 10. Well, we're going to put 5 and 5. So what happens is we can rewrite this. This is the next part. It says then factor the resulting perfect square trinomial. And what they want us to do is they want us to say, well, that's the same thing as x plus 5 in parentheses squared. Because we have 2 x plus 5s here in different parentheses, you can combine them into 1 with a squared. So this right here is like our answer. Same thing on number 4. This one is a little bit trickier because when we start this process and we say, okay, take the number in front of x, divide it by 2. Oh, ouch, that doesn't divide. Well, so 3 divided by 2 is 3 halves. Now we're ready to square. To square that, we square the top, get 9, square the bottom, get 4. That's the number that goes right here. Now, to think about what factors we're saying, what do I multiply together to get 9/4 that adds to get 3? Well, think about what we multiply together to get 9/4. Wouldn't that be 3 halves and 3 halves? Because that's what we just did down here. And it turns out if you do add those together, you get 3 because that's 1.5 plus 1.5. So that means we would write this as x plus 3 halves squared, like so. Now on 5 and 6, we're actually going to solve an equation by completing the square. The 2 we just did just had us complete the square in general. Now we actually want to solve an equation. So the first thing we do on these problems, which are incredibly similar, it's just that way we can practice on more than one. First thing you want to do is you want to write it the right way. So we want to subtract 15 over in this one over to the other side because we just want the stuff that has x's to be on the left. And we're trying to fill in the blank here and say, what do I put there to complete the square? So we take 8 divided by 2, which is 4. We square it and we get 16. So we have to add 16 right here, but if I add it to one side so I can complete the square, I have to add it to the other side to keep my equation balanced. So now 8 x squared plus 8x plus 16, that factors into x plus 4 times x plus 4, which means we can write that as x plus 4 squared. Negative 15 plus 16 is 1. Now the whole point of us doing this is that now we can use the square root property to square root both sides and actually figure out what x is. So x plus 4 equals, the square root of 1 is 1, and since we took the square root in an equation, we have to put a plus or minus sign. Then I would subtract 4 from both sides, and I get x equals negative 4 plus or minus 1. If both of these two things are actual numbers, then we can figure out the actual two answers, okay? Because one answer is negative 4 plus 1, one answer is negative 4 minus 1. That's what plus or minus means. It means there's two answers. So negative 4 plus 1 is negative 3. Negative 4 minus 1 is negative 5. So our two answers are negative 3 and negative 5. Notice that I didn't just say, oh, positive and negative 3 or something like that. I didn't just try to add these numbers together and then put a plus or minus in front. That's not what happens. You have to break it up into two separate things. So same exact situation going on here for 6, just with different numbers. We need to start off by writing it where I have a blank here and I subtract 67. So I need to figure out what to put in this blank. To do that, I take 18 and divide it by 2. I get 9, and I square that, and I get 81. That's what I'm going to add here, but since I add it to one side, I also have to add it to the other side. Now we factored on the left. What multiplies to get 81, that adds to get 18. You do 9 and 9, so that's x plus 9 squared. Negative 67 plus 81 gives me 14. And now I'm ready to square root both sides and actually figure out what x is. So on the left, that leaves us with x plus 9. On the right, we can't actually simplify the square root of 14 because that's 2 times 7. So there's no pairs of numbers. So that's plus or minus the square root of 14. Subtract 9. Get x equals, since I can't actually add these together, one's a square root and one isn't, I just write my answer like this. Negative 9 plus or minus square root of 14. Number 7 and number 8 say use the quadratic formula to solve, so let me just jot down the quadratic formula. Negative b plus or minus square root of b squared minus 4ac all over 2a. So the first thing to establish on problems like these is what is a, b, and c. A is always the number in front of x squared, b is always the number in front of x, c is always the number that's left over, and notice they go in order, a, b, c, first number, second number, third number. As long as this starts off in standard form, that'll be the case. And if it ever skips one, you would put a 0 wherever it is. So we need to fill in. The webcam's not on.
Just want to take a picture.
Negative 12 plus or minus square root b squared minus 4 times a times c over 2 times a, so 2 times 1. Now this looks tricky to simplify, but you really just have to take it in a few steps. The first thing we want to do is figure out what is going on underneath the square root. So 12 squared is 144. Negative 4 times 1 is negative 4. Negative 4 times 23 is 92. So 144 minus 92. 2 times 1 on the bottom is 2. Negative 12 stays what it is. 144 minus 92 is 52. And then we want to check to make sure that we can't simplify square root of 52. So I'm going to make a factor tree for 52. I know it's divisible by 2, but that's 2 and 26. oh, not but, so 2 and 22, 2 times 26 gives us 52. 2 times 13 gives us 26, so we can actually simplify because we have a pair of 2's. So this is negative 12 plus or minus 2 square roots of 13 over 2. If you can divide everything here by a number, leaving out the square root is protected. Okay, but if all three of these numbers are divisible by something, you can do that and simplify. So that gives us, because they're all divisible by 2, that gives us negative 6 plus or minus 1 square roots of 13, which we don't need the 1, over 1, which again we don't need the 1. So this right here is our answer. So on 8, figure out what A, B, and C are. And you might try pausing the video and seeing if you can do 8 on your own, and then starting it back up once you're done with your try and see how you did. So A is 1, B is 3, C is 1. So we fill in our good old handy dandy quadratic formula. Negative 3 plus or minus the square root of B squared minus 4 times A times C all over 2A. So we start off by simplifying the square root sum. 3 squared is 9. 4 times 1 times 1 is 4, so that's minus 4. 2 times 1 on bottom is 2. So 9 minus 4 is 5. Can't simplify the square root of 5. And since there's no number outside the square root, even if there was, we couldn't simplify because 2 and 3 don't simplify. So this right here would be our answer. We're done on that problem. Okay, the discriminant is part of the quadratic formula. It's b squared minus 4ac. And if you get, for the discriminant, a number that is positive, then that means there are 2 real solutions. If you get 0, that means there is 1 real solution. And if you get a negative number, then that means there are 2 imaginary solutions. I'm not 100% sure that I spelled imaginary right, but it's whatever. So we don't have to do the full out quadratic formula and actually find the answers. We just want to do b squared minus 4ac. So here a equals 1, b equals negative 7, c equals negative 8. Make sure if you plug in negative numbers that you put them in parentheses. Negative 7 squared is 49. 4 times 8 is 32, and since we've got 2 negatives, it'll be a positive 32, giving us 81. What matters is that that's a positive number, which means that we have 2 real solutions. So again, here you could pause the video and try these next 2 on your own to see how you do, and then start the video back up once you see b squared minus 4ac. So that's 36 minus 36, which is 0. That's 1 real solution. Wow, these happen to go in the same order as my little chart thing over here, but that probably won't happen on the test. We'll see. A equals 1, b equals 3, c equals 6. So b squared minus 4ac. So that's 9 minus 24, which is definitely a negative number, negative 15. So that's 2 imaginary solutions. Write a quadratic equation in standard form with the given solution set. So this is where we're like unfactoring in a way. Because we want to do is we want to say, well, x is equaling 7, x is equaling 10. So we're subtracting the numbers over to the other side to put them in as factors. So whatever sign these have, 7 and 10, we're going to have the opposite side when we put them in our parentheses. So that's x minus 7 and x minus 10. And then we want to FOIL this out to actually get our quadratic equation. So x times x is x squared, x times negative 10 is negative 10x, negative 7 times x is negative 7x, negative 7 times negative 10 is positive 7d. Add the middle terms. And this right here is our answer. Now this one may look scary on 13 because of square roots, but it's really not that bad. So you change the signs, although on this one it doesn't really matter. You're going to end up with one being positive and one being negative. So if we FOIL, we get x squared. Outer is negative square root of 3 times x. Inner is positive square root of 3 times x. And last, square root of 3 times negative square root of 3 is negative square root of 9. Or if you can jump there, it's actually going to end up being negative 3 without a square root. The middle terms here cancel out because they have opposite signs, but otherwise are the same thing. So this is x squared minus 3 equals 0. Now, when we were doing this, there is actually a pattern that happens that you end up, if you just start with whatever your solution set was, like if we started with 7 and 10, the middle number is minus what those two are added together, times x. See, 7 plus 10 is 17. We got negative 17. So we have to change the sign of whatever we get when we add these together. So in this case, it doesn't really matter about the negative, because if we add these together, we get 0, and notice how we didn't have an x term. And then the last term, you get just by multiplying. 7 times 10 gave us 70. So you multiply to get the last number. Negative square root of 3 times square root of 3 is negative 3. So this actually is like a pattern or a shortcut that you can use now on a more difficult problem like this one. What we need to do is we need to add them together, and then we need to multiply them together and see what happens. Okay, when we add 8 plus I and 8 minus I, we add like terms. 8 and 8 is 16. I minus I is 0, so we just get 16 when we add them together. When we multiply, we have to FOIL, so 8 times 8 is 64. 8 times negative I is negative 8i. I times 8 is positive 8i. I times I is negative I squared. So these cancel in the middle. Remember that I squared is negative 1. So that's 64 minus a negative 1. So change. We get 65. So this one gives us x squared minus what we got when we added together. So we got 16, so that's minus 16x, plus what we got when we multiplied together, which is 65, equals 0. And believe me, or take my word for it, that's a lot easier than if we had to do x minus 8 plus I and then x minus 8 minus I and figure out what that is. We did it a much shorter way, even though it may not seem like it. Sketch the graph of the quadratic function using a table of values. We have two problems with this, and it matters what form this is in. This is called vertex form, whenever you have the parentheses like this, and it's called that because it tells us the vertex. You take what's in the parentheses and you change the sign. You take what's outside the parentheses, you leave it alone, and that puts our vertex at 2, negative 4. So we put that in the middle of our table. Okay, you always want the vertex to be in the middle. And then you pick numbers for x that are near that number. So we're going to pick 0, 1, 2, 3, and 4. And now we take that original equation and we're going to plug in 0, 1, 3, and 4. So if I plug in 0, this first part is negative 2. Negative 2 squared is 4. 4 minus 4 is 0. So we have 0, comma 0. Then we plug in 1. We're plugging it in where x is. And 1 minus 2 is negative 1. Negative 1 squared is 1. 1 minus 4 is negative 3. So we put negative 3 there. Now plug in 3. So that gives us 3 minus 2 is 1. 1 squared is 1. Minus 4 is negative 3. Four minus 2 is 2. 2 squared is 4. 4 minus 4 is 0. Now, what we just had happen here, where these two are the same and these two are the same, that should happen every single time if you actually work it out correctly. Now plot your points. 0, 0. One comma negative 3. 2, negative 4. 3, negative 3. And 4, 0. Also, these should give you U-shaped graphs, so if you get something that is not looking either like a U or an N, then something probably happened and you need to go back and check your work. It's kind of hard for me to draw the way I'm recording this, so sorry about that. That's my problem. It's like a smiley face. Okay. Sketch the graph of the quadratic function using a table of values. Now this is not vertex form, it's standard form. And when we're in standard form, the first thing we want to do is still find the vertex, but we actually have to do some work to find the vertex. In standard form, we use the formula negative b over 2a. So we know that a is 1, b is 4, c is negative 7, just like if we were doing the quadratic formula. But all we have to do is this part, negative b over 2a. So that's negative 4 over 2 times 1. Negative 4 over 2 is negative 2. So we put that in the middle for x, and then we pick numbers that are around it. So 0, negative 1, negative 3, negative 4. Or you could put those in the opposite order. And then we have to plug all these numbers in this time for x, as opposed to last time where we already knew what the vertex was. 0 squared is 0. 4 times 0 is 0. 0 plus 0 minus 7 is negative 7. Plug in negative 1. Make sure you put it in parentheses because it's a negative number. This gives us a positive 1 minus 4, which is negative 3. Negative 3 minus 7 is negative 10. Put in negative 2. That's 4 minus 8, which is a negative 4. Negative 4 minus 7 is negative 11. Put in negative 3. So that's 9 minus 12 is negative 3. Negative 3 minus 7 is negative 10. I have been putting these in my table of values. And negative 4. So that's 16 minus 16, which is 0, minus 7 is negative 7. Notice we have this symmetry thing going on again. That's good. We want that. So we need to plot these points. 0, comma, negative 7, negative 1, negative 10, negative 2, negative 11, negative 3, negative 10, negative 4, negative 7, and then connect your dots in a parabolic fashion. Alright, solve the equation by factoring. So even though these have x to the fourth instead of x squareds, we can still split them up into a couple parentheses. But instead of putting x's here, because x times x gives us x squared, we actually have to put x squared, because x squared times x squared is x to the fourth. So we need to think about what multiplies to get 100 that adds to get negative 29. So I think negative 25 and negative 4 would work. And then we split this up, setting them each equal to 0 so that we can finish solving. So on the first one, add 25, get x squared equals 25, square root both sides, get x equals plus or minus 5. That's our first set of answers. And then do the other one. X squared equals 4, square root. So x equals plus or minus 2. Now you try 18 and see how you do, and then, unpause when you're done if you want to be challenged. So what multiplies to get 6 that adds to get negative 7? That's hopefully a kind of an easy one. Negative 6 and negative 1. Set them each equal to 0. And solve. So here we add 6 to both sides and get x squared equals 6. We square root. Oh no, there's no square root of 6. Pretend that's not there. So x equals plus or minus the square root of 6. We just leave it alone. Add 1 to both sides. Get x squared equals 1. Square root both sides. X equals plus or minus 1. So there are our answers. And now polynomial inequalities. So what's important here is that you remember if you see less than, that means that it's an and problem, which means that you end up shading between two numbers. If it's greater than, that's an or problem, which means that you shade out from your 2 points. So this first one is a less than. And so the 2 points we're going to pick are where, if we separate this and set them equal to 0, those numbers we get when we solve. So the first one, you subtract 1 and get x equals negative 1. First, and then add 3 and get x equals 3. So those are the numbers that are important on our number line. We're not equal to, so we need either open dots or parentheses is really how we talked about it earlier in the year whenever we did inequalities. So whichever you want to use is fine. We said it's less than, which is and, which means we shade in between. And they ask us to express this as interval notation, which is where, since it's not equal to, we put parentheses, and we're saying it has to be between negative 1 and 3. With inequalities, we would say, well, x has to be between negative 1 and 3. So typically we write it like this. On 20, we have to do some work to factor this. It is greater than, so that means it's an or problem. But we need to multiply to get negative 28, that adds to get 3. So positive 7 and negative 4. So that gives us x plus 7 equals 0, x minus 4 equals 0. So x equals negative 7, x equals positive 4. It's not equal to, so we need open dots or parentheses. It's or, so you shade out. Our inequalities on this is that x has to be less than negative 7, or x has to be greater than 4. How do I know to put or there? Because this is an or problem. The set notation for this, we're going over here from negative infinity to negative 7, and then we're going from 4 to infinity. So that's our set notation. Let's try this now with some rational inequalities. So this is going to be an or problem because of the greater than. We need to set the top and the bottom equal to 0. So x equals positive 3, x equals negative 4. So we put our open circle or parentheses, shade out. And if we wanted to write this as inequalities, we would have x is less than -4 or x is greater than 3. And as set notation, you go from -infinity to -4 and from 3 to infinity. This is less than, so it's an and problem, so we'll shade between. Set each part equals to 0. And put those two numbers on our number line and shade in between. So our inequalities would be -5 is less than x is less than 3. And our set notation is that x is between -5 and 3. So that's all there is to it.